Hello friends, this is Sanchit Mehra and I am back again with another tutorial on vectors, and this time I would be explaining about how we can remove elements from a vector, whether we can remove it from the front, from the back, or some kind of a range from the middle. And we would also be learning about the time complexities that would come while erasing the elements in a vector, and what all are the methods or functions provided to optimize the deletion of elements or erasing of the elements in a vector. Okay, so friends, let's start with creating a vector of an integer. So let me create it a vector and of an integer. Let me call it as v1. Now to insert an element, we use a method which is pushback. Let's enter like v1 dot pushback to my dear friends, if you know about C++11, then it gives you a initialize list by which you can initialize the vectors as well. So instead of doing this, you can straightforward do it like this, 1 comma 2. So this would be as this one. Okay, so this is an initializer list which is in standard C++11 and onwards. So you can initialize it like this, and let's iterate our array to see the contents of our vector. So this is just a log here. So vector initialize, or you can say initially. Okay, and let's take the auto it equals to v1 dot begin, and it is not equal to v1 dot end, and plus plus. So C++11 also provide this auto keyword in which the type of this iterator is automatically deducted by the compiler. So no longer syntax and no longer big you can say declarations of iterator is avoided here, and it becomes quite easy here. Okay, so we can just print the elements here. It would be star of it and stdendl. Yeah. So now let's go and see whether all compiles perfect, and we see the vectors are initialized and have these elements from 1 to 7 as per we have given the initializer list to it. So this is the syntax, my dear friends. If you are using a C++11 standard, this is the way you can initialize the vector as well. Okay, so now let's come and see how we can remove the elements. Okay, so let's say let's study about how you can remove an element from back. Let's say you want to remove this element. Okay, so there is a method that is provided by vector is pop back, and it just remove an elements from the back. Okay, so you can see it's the time complexity would be O of 1, because while you're removing the element from the last, there is no repositioning of the elements that are required. So 1 would be at 1, 2 would be at 2. You're just removing the element from the last. Okay, so there is no resizing that is involved here. It is done in O of 1 time complexity. Okay, so it would be simple. You can have v1 dot pop back, and it would be removing the element from the last. So we can now see after doing that vector after, and we are just again taking iterator and just iterating it. So my dear friends, there is one more way of iterating the iterator, is that you can take the size of the vector and you can iterate from index 0 to size -1 by the virtue of the fact that they are arranged in a contiguous memory location. It's just like an array, so you can just take that. Okay, but since after deletion the iterators got invalidated in our vectors, so it's better, and in my opinion, to take an iterator again and just iterate the array or the vector again like this. Okay, so let's see after pop back what we have as an output. So let's see, here we have 1 to 7, and now after popping back we have 1 to 6. So if you want to further remove it from the back, it is quite an efficient method here. You can just do that, and you see that this elements, the 6 and 7 elements from the last, is removed. Now if you want to remove an element from the begin, so in that case you have a function, or you have a method here which is called as erase. Okay, so there's two overloaded erase, so I'll be using the first one here, and then I'll explain you about the last erase method. So first one is taking the iterator. Okay, so the position, the position, or you can say the iterator that points to a position. So if you want to remove the first element here, you just need to pass in the iterator that is pointing to the first element, and in that case would be v1 dot begin. Okay, so this would be an element which would be pointing to the first element, and so my first element would be erased here, and here the time complexity would become O of n. Why? Because all these elements would have to be repositioned or reshifted to left hand side. Okay, so you're removing 1, then 2 shifted to 1's place, 3 shifted to 2's place, and so on up to the n elements, and so the time complexity become O of n. Okay, so let's see and run it. So you see here that my vector is 1 2 7 here, and after having an erase method it becomes 2 3 4 5 6 7, right? Now let's come, if you want to erase, you can say arrange. Let's say you want to remove an element from the first 3 elements. Okay, then how would you go is to use the second method, overloaded method of erase, which is this one. So my first would be this one, the iterator that is pointing to the first one, and it is included. Okay, what I mean by included is that this the position, the element would be erased as well. Okay, but the last iterator would be excluded. I mean, if the last iterator is pointing to 4, then all the elements before 3 or before 4 would be removed. Okay, up till the element that is pointed to by the first iterator. Okay, so I have to remove first 3 elements here. So the first one would be v1 dot begin, and then I need an iterator to here because I want to remove 1 2 and 3. So my last would be this one, fourth one. So what would be the value of iterator here would be vi dot begin plus 3 element plus 3, so 1 2 and 3. Okay, so it would be v1 dot begin plus 3 here. So you can see 1 2 3 is removed, and 4 5 6 7 is my new vector here after removing. So it helps us to erase the range as well, or in particular if you want to erase an element using the index or using the position. Okay, so in that case the erase is helpful if you want to remove certain elements and you know the position of the elements and you want to remove that, erase this from the vector, then in that case this is a very, very helpful method. Okay, now you do not give the index, so you do not know the position, but you just know the number that I want to remove this element from the vector. You do not know the index, but yes, you know the element. Okay, you know the value of the object or the element. Okay, so let's say I want to remove a 5 here, and 5 comes 2 times here, let's say. Okay, and you remove the element 5 from the vector v1. Okay, so here we have a function here which is std remove And here you have to give a range from where to start and from where to end. Okay, and it would search that element in that range only, and it will, you can say, remove it. I would say it would logically remove the element. Okay, your vector would not be resized, your vector would be same as it is. The size of the vector would remain same, nothing would be erased, but it's called a logical delete. The element you want to remove in such case, let's say it's 5, so let me include 5 here. Okay, it would be something better to understand. Okay, so what remove it do is to move the element 5. Suppose if I want to remove a 5, remove this 5 and this 5 to the back of the vector, or you can say the last to the last of the element, and it would give you a new range which would be 1 to 7 excluding 5. Okay, so 5 would be shifted at the last, and you would be having a new range here to iterate an array. Okay, so still the elements are not removed here, or you can say it's logically removed. Okay, because the size of the vector is remaining the same, it's not getting resized as it was a case in erase case. Okay, in erase the vector size was getting reduced, but how the remove is working, let's study that. So I'll give the range is v1 dot begin and my range is v1 dot end, so complete vector, and I want to remove an element 5. Okay, so let's see what would be our vector in this case. Okay, so it's still not complete, but let's see how my vector internal state is. Okay, so let me run it. So we can see here vector R initially is 1 2 5 3 4 5 6 7, but here you see 1 2 3 4 6 7, and this is something which is undetermined. Okay, this is the value which is undetermined by the vector because it has now shifted all the elements and your 5 is removed, but it would give you, but the point is, how would you know what would be the new range? What would be the new range? You need to know that. So std remove gives you that last iterator, the new end of the vector. Okay, so auto itr end would be the new end. So in this case itr end would be this, so that when you iterate from 1 to itr end you will get all these elements. Okay, so instead of v1 dot end I will be having this. All right, so it is just, you can say, moving the elements. Okay, and it's logically deleting 5. Okay, but the size of the vector remains the same. Okay, so if I run it now, you could see the vector is 1 2 3 4 6 7, and the 5 you do not see it because all the elements are shifted and the two spaces at the end was indeterminate state. Okay, so itr end gives you that last position of the iterator. Okay, so this is the point which we need to be sure. Okay, but here the point is we are not having v1 dot end. Why? Because the vector size is still the same, and now we know that after this 1 2 3 4 6 7 my vector is of no value. The spaces left, or the, you can say, the iterators beyond this 7 is useless to us and we want to erase that. Then again you could take a help of a erase function that I have told you earlier. So what you can do is v1 dot erase, and what you want to erase is that this is the starting position or the iterator at that position, and you want to delete it up to the end of the vector. So this will erase all elements, as I have studied, as I've told you earlier about the deleting the range of, you can say, range of elements in an array. I use the second overloaded method of erase and I pass the position of the iterator. Here I am passing it itr and, which is, you can say, the beginning of the element, or it's a return of the std remove, which is the beginning of the, you can say, the begin of the begin iterator for this erase method, and up till the end of the vector I want to get rid of it, and I want to now erase that part. Okay, so after this erase, the vector would be resized, and here now I can perfectly put v1 dot end here. And now when I run it, you can say now after putting it erase here, I could have 1 2 3 4 6 7. Okay, so my vector is resized now, and my iterators are again refreshed. Okay, when I use the v1 dot erase. Okay, so at this itr end, I can simply write this, and let me put it as v1 dot end, and I can remove this as well, or I can just comment out to this. Okay, so this becomes a one line code of removing a range of or you can say some kind of elements. Okay, it could be at multiple places. So what is the benefit of std remove is that after removing each element, or you can say it does it at one time. Okay, the shifting of the elements happens one time. That's not the case with the erase. After every erase you call, the elements would be reshifted, but this is not the case with remove. The shifting of the elements will happen only one time. Okay, and so once you have an iterator from where you want to remove to the v1 dot end, where up till that point you want to remove that uh, the vector, the positions of the vector, and you can resize the vector here. Okay, so this is the thing, this is the one line of code that you can achieve it, and will give you the same output here. Okay, now second thing I want to make you understand is there is one more function, which is std remove if. Okay, so in that I would be giving the range from where to proceed up to which end you have to check, and the predicate here. Okay, suppose I want to remove the elements which are odd. Okay, so again here I would be given v1 dot begin, v1 dot end. This is the range I want my algorithm remove if to check my elements. And what they have to check, I just need to provide a predicate function here, which when returns true will remove that element. If that predicate for that element would return false, it would not remove that. Okay, so I'll make one predicate here, which is bool is odd, and I will be passed an integer here, and I would return n mod 2 is not equal to 0, then it is an odd function. Okay, and I would pass this predicate here. Now what this remove if would be doing, for each element from v1 dot begin to v1 dot end, it will iterate each element and it will pass to this predicate is odd, and each element in the vector will be evaluated, and once it returns true that it is an odd, it will remove that element. So again here, as I've told you in remove, the logical shifting would happen. Okay, so it would logically shift that, it will logically remove it. Okay, actual removal will happen with v1 dot erase, when you pass the iterators from where to where you want to erase the elements from the vector. Okay, so now let's see and run it. So now you see 2 4 6, this is the elements that is left, and it becomes quite an efficient way of, you can say, erasing the elements from an array. So remove if is logically done. Okay, not such a great performance hit. And now when you have the iterator from where you want to remove the elements from to the end of the vector, so you have this iterator which is returned by this algorithm, which will be written by this function. Okay, after this including this, and after this iterator, all the elements could be removed easily because they are the elements which passed with this predicate and needs not to be considered. And so you can call v1.erase on this iterator, and you can say the vector could be now erased. Okay, so it was logical and it was actual erase of the vector, okay, of the elements in the vector that you want to remove. Okay, so friends, this is the thing, and do let me know what all, if you have any doubts in this, in vectors removal. We would be taking up more lectures on vectors and go more deep dive into the time complexities, into the memory organization, what are the best way of using the vectors. Okay, so this is all, my dear friends. If you like the video, please press the like button and do subscribe for more such useful and helpful resources in C++. And I wish you all good luck in your preparations, and see you in next video. Till then, goodbye, keep learning and enjoy. Bye bye.